So, one thing you'll note is that you cannot just use the expression for spectral density versus frequency and substitute uh, express frequency in terms of lambda. You have to multiply that by c over lambda squared. So you cannot just replace nu by c over lambda. Remember, lambda nu is equal to c, right? So let's see why that is. For example, what I meant to say there is that here, okay, you cannot just say that this is, you cannot just say that the spectral density per unit wavelength is equal to 8 pi, and then nu is c over lambda, right, over c cubed times h, and then c, nu is c over lambda over e to the h, nu is c over lambda kt minus 1. Okay, you cannot just do that. You have to have an extra term here that says c over lambda squared. Okay, so this is a spectral density per unit frequency. This is, multiply that by this expression, you get the spectral density per unit wavelength. Why is that? Well, here's a way of looking at it. You need to realize that, okay, the integral from nu1 to nu2 of rho of nu at a given temperature, integral from nu1 to nu2, that should be the same as the integral from lambda equals c over nu1 to lambda equals c over nu2, okay, of rho of lambda t d lambda, this expression right here. Okay, so if we're going to do a change in variables, our integration variables, then what we have to say, what we say then is d nu is equal to d nu d lambda times d lambda. Okay, so it's like saying d nu, d lambda cancels out, right? So what is d nu with respect to lambda? Nu is equal to c over lambda. So if you take d nu with respect to lambda, then it's like saying y equals constant over x. What is dy dx? It's going to be negative c over x squared. So this is going to be negative c over lambda squared. Okay, so d nu then is this. So let's rewrite this one right here. This is equal to integral of rho of nu t, spectral density per unit frequency, times, instead of d nu, I'm going to write d nu d lambda times d lambda. Okay, so d nu over d lambda is minus c over lambda squared. Okay, and so since I have changed my integration variable, my limits would now be in terms of lambda. So this is when lambda equals c over nu 1 to lambda equals c over nu 2. Now, let's call this lambda 1 and let's call that lambda 2. Since if nu 1 is less than nu 2, you're integrating from nu 1 to nu 2, for example. Okay, nu 1 to nu 2. If nu 1 is less than nu 2, then you know that lambda 1 is going to be greater than lambda 2. So if you want to start from the lower lambda to the higher lambda, you switch these limits. Okay, so you integrate from the lower lambda, which is going to be lambda 2, to the higher lambda, which is lambda 1. This is going to be, and if you're switching limits, then that negative sign disappears. Okay, if you switch limits of a definite integral, you get the negative of the original. So this is going to be rho of nu t c over lambda d lambda. Okay. Oops. So this expression right here, c over lambda squared. Sorry about that. Nu okay, times c over lambda squared d lambda. So this expression right here is the spectral density per unit wavelength at a given temperature. Okay, and so that's what we have up here, right here. Okay, and if you did that, what happens? You have, remember, rho of lambda t is rho of nu t times c over lambda squared. So that's going to be equal to 8 pi nu is c over lambda squared over c cubed times h nu, and nu is c over lambda, divided by e to the x, which is h nu over lambda, and nu is c over lambda, h nu over kt, and nu is c over lambda, so hc over lambda kt minus 1 times c over lambda squared. Okay, so you have, to simplify this, you get c cubed in the numerator. You have c squared and c, that cancels out c cubed. You have 8 pi hc over, you have lambda, oh, that's lambda squared. There's another lambda, so that's lambda cubed, and there's another lambda squared, so that's lambda to the fifth, okay, times, so the h is already taken care of here, so times 1 over e to the hc over lambda kt minus 1. And that is the expression that you have in the textbook, and that's the same one that we have right here. Okay, 8 pi hc over lambda to the fifth times 1 over e to the hc over lambda kt minus 1.